create these D-apps a lot easier than using regional director, but with this blockchain stuff, the CPA inside of the blockchain. So now, instead of having to write everything into the actual implementation of the blockchain, you can implement, we're going to be using Ethereum as an example, you can execute these individual smart contracts and program these individual smart contracts, and it's basically a set of immutable code posted right inside of the blockchain that you can interact with. So developers should start thinking right away. Do you change a smart contract after it's deployed? No. So there's certain limitations, but that's also its draw and why it's such a different type of an implementation. So now, instead of just writing a transaction in there, we can actually deploy a smart contract and interact with that smart contract. So same way as we put it into the blockchain with maybe something like Bitcoin, transferring money, a financial type of a transaction around, we now have this code. And it could be transferring money around, but it can be doing so much more too. And this is where you see this, oh, you know, blockchain is going to be this whole next coming of the internet, bigger than the internet and so forth. But it really gives you this capability of saying, hey, I'm writing this transaction once. I know, and you know, for CPAs and accountants and auditors, I mean, this is just like heaven. And I can rely on that. But now, instead of having to write, you know, this whole transaction from scratch, we can post this smart contract into the blockchain and have executable code and state within that contract. So you can do things like store variables into it and update individual variables. So all of a sudden, oh, there is some way to actually update. Well, you're not really updating inside of the blockchain. You're creating transactions inside the blockchain that maintain a state in an executable. So dApps. Oh, I got these out of order, didn't I? It's really a workflow. Let me jump up here. Okay, so a dApp, and what makes up this whole type of a scenario with these smart contracts? Because you're really talking about multiple things here. And the thing that we're going to kind of concentrate on tonight is the smart contract. And really the smart contract is the easier part of the equation. Because basically what you're doing is you've got this blockchain data, the smart contract goes into it, and also there's this idea of a swarm of files, there's other types of file structures, but basically placing files into an Ethereum virtual machine. So the whole Ethereum is basically a virtual machine that is loaded up and you start interacting with it. The way you interact with it is through these smart contracts. And you can interact with it with HTML, JavaScript, CSS. Yes? No.
So, thank you, and I have two questions. First is like, does blockchain include the process to verify and validate the data into the ledger or not? And the second question is for dApp, D-A-P-P, is that stateless or not?
So, the two things of blockchain, it's immutable and the transactions are verified. And you know, there's this whole mining and proof of work and, you know, proof of stake types of validation procedures. And we aren't going to get into that. You're going to have to just take my word for it. Because we're going to say, hey, this is the 101 part on blockchain. Now we're jumping into the smart contract part. But just kind of in the back of your head say, hey, why do this? Why do we want to do this? Because it's immutable and the transactions are verified. Distributed, mining, proof of stake, proof of authority, I think is what the workbench is working under now. All of those things go into those two characteristics of what blockchain are. And it affects what you're doing with smart contracts because they are immutable, although they have these variables that can maintain state inside of them. So there's something called Solidity that we'll talk about shortly, and you write the smart contract in that, and the contract is basically a class. And the class has things like inheritance. So I think somebody was saying, oh, we put two contracts together. Very common type of a scenario. You're going to have one class inheriting from another one, and we'll see that when we deploy it to Workbench, that basically Workbench is another contract that interacts with the system, with what's known as an oracle. So you have these pieces of code. You also have the account or wallet in the financial types of scenarios when you're trading Ether, Bitcoin, and et cetera, et cetera, et cetera. You have this wallet that's maintaining your balance, but it's also your identity. So your account that's going into it. So all of a sudden, oh, we've got all this code that has to interact with the contract. We also have to maintain these individual addresses, addresses, accounts, wallets that are also interacting with it. Because somebody's every time that you're going to be posting a transaction, it's going to be tied to an individual account. If you're transferring money, you're going from one account to another. So being able to control this type of a scenario also makes it somewhat difficult. So you have an identity issue. If you're doing the wallet thing, that's fine. Everybody's got their identity, their wallet, their private key on their own individual computers, and they're interacting in that type of a fashion. But what if you're going to be deploying these smart contracts within an enterprise to communicate with other enterprises? So, and something to maybe take from this is that, hey, you aren't just going to deploy blockchain for everything. It's going to be more of enterprise to enterprise, or unless you really have departments. Usually, it seems like the proof of whether blockchain would work is there some kind of reconciliation or trusting party between the transaction? So we have this DApp, distributed app, and it's really made up of all of these things. You've got the contract that the application is working against. You have an account that is the identity for the individual transactions that you will be posting against the individual contract. And you could have these swarm of files. There's also other file systems out there, all part of this Ethereum VM. Yes?
Why do you say the client-side app is the hard part and the block? Why you have like a client-side app, you call it hard part and the harder part?
Well, I didn't say, I said it the harder part.
Why?
You're going to see. Okay. I'm just kind of laying this out. And actually, when you see it, I mean, the Solidity itself, most programmers are going to feel very constrained by it. Like just crazy stuff. There is no date type. You deploy it, you're done. You want another one? You deploy another one. Don't have to worry a whole lot about version control. Only when you're up to the point of testing and debugging. But once you deploy it, that's it. It's part of the blockchain. It's immutable. And that's the characteristic that really pulls out, and that it's all verified, that it's correct. But this is the characteristic that immutability is why blockchain will be adopted by enterprises. And why the CPAs love it so much. So think of a ride-sharing DApp. Let's say if I wanted to get a ride, I could pull up this DApp and it would post it out into the blockchain, and you'd have writers that can view that request. And then maybe the writers say, I'll do this for this certain amount of money. Or even as part of the contract, you come up with an amount of money to be performed. And then the writer says, I could give you a ride, and then you select that individual ride. And when the ride's completed, oh, wait a second, that money gets transferred over to the driver. And then you rate the driver. So basically what you're talking about when you're talking about these contracts, they're workflows. You could have a single-step workflow, which is what we're going to write because it's real simple. But they're basically workflows that you are defining through the code. So let's take it a little further. So we have the parts of what creates a distributed app. And by the way, you can actually take these files, put them into the swarm, and one of the things is that this can be distributed across multiple different owners, locations. That's all part of the verification process. No disaster recovery required with blockchain. Well, except you have to have more than one location for the nodes. And there's actually 3 types of dApps. Convert assets to crypto assets. It's the ultimate. Vote, reward systems. So these are actually defined out there on ethereum.org as different types of apps. So we have transactional, financial, and then we have this big other. Well, once you start playing with it, you realize that anything that can take advantage and maybe cut out a middleman, like we were just talking about that ride-sharing app, you don't need Uber or you don't need Lyft adding expense, do you, anymore? Oh. Or IRS? Well, they're trying. If you had anything in Coinbase, if you knew that. Not that anybody sells any of that stuff or uses it for transactions. So yeah, and you can certainly do, I mean, it's kind of cool because we went back, we were saying, hey, part of this is that account wallet that can be just kind of sitting out there. That's, you have a public key that you can see, but you really are somewhat really anonymous. You can trace the transactions, but all you're seeing are these public keys unless you can tie the two together. You could create this anonymous type of scenario. But I think the vast majority of the smart contracts are going to be more of an enterprise to enterprise, or within an enterprise that is very diverse. Like one department doesn't trust another one. Can't imagine that happening, right? And say, okay, we'll put it in the blockchain. And then you can audit it at any time because it's immutable and verified. So, how do we start working with these individual smart contracts and create this distributed app or dApp? I've been using Ethereum. We're going to be using Ethereum throughout this. You can use other types of things. Hyperledger is a very popular one also that supports the smart contracts. Ethereum was first. But you can actually set up different networks beyond the main net and be able to post directly and deploy directly into these other implementations of Ethereum. So as you're setting up your development environment, you aren't going to be writing right against the back end. However, with the Azure Workbench, I see that eventually coming into integration. But you have these different networks, Robstein, Wrinkly, Kovan, that you can attach to. You also can create a JavaScript VM, or you can connect into any other type of existing blockchain to create your development environment. And you need this account. So you have to start with some type of an account. And probably the best way to do this is using something known as MetaMask. That allows you to create an individual wallet and attach it to the different individual Ethereum networks that are out there, including your own individual VM that can be fired up right within your individual IDEs. And if you need some Ethereum, because the way that this works, and this is thinking of it on a public basis, there's this concept of gas with Ethereum. So you're basically, if you're writing a transaction in there, you're spending something. So if you want to do a denial of service, well, I guess if you have enough money, it kind of defeats the purpose though. That's one of those cool things that's kind of built into this whole verification process. In the public. In the private, you don't need to really worry about gas. But in the public, you do. But you can go out and actually just get it and fill it into your individual different types of Ethereum networks that you're working with to create your application. So very easily, once you've got these set up, you can just transfer from one account to another. Now let's take a quick look at that. So I'm going to go up in here. And if you're really into blockchain, you got to be using the Brave browser. Basically, it does all ad blocking, and it has its own cryptocurrency, so that the idea is eventually that people that you like, you'll get their information and you'll give them some of this cryptocurrency. But check it out. It's basically the Chrome implementation, but no ads. It even gives you the stats. Let's see, I set this up recently. I've had 106 trackers blocked, 356 ads blocked, and it is pretty fast. Brave. And I think it might be brave.com. Kind of cool tab page. But anyway, what I'm going to do is notice, and built right into it, since it is a blockchain type of a thing. Let me go to the settings here and go into the plugins. Oh, sorry, the extensions. And you'll see that MetaMask is right there. Otherwise, you can get it from the different stores for the different browsers and install it. Here, it's right with the extension reference. Just turn it on, and away you go. So remember, this was back a couple slides where I was saying, hey, how do we start deploying this and testing the individual programs? So what happens is that you get a MetaMask extension. And I happen to have it connected into the Rinkeby test network. I don't know why it's taking so long. But you can see all the different test networks that are available to you. You know why it's taking... I am connected. Let's see if I can connect in here. There we go. Got it. It's probably Brave is still considered beta. So every now and then you'll get that, sorry, I couldn't do anything, you close it, and then you just launch it up again. So notice I have an individual account there, and I could even have multiple individual accounts. What I did was actually fill it up with some Ethereum. Well, you just go to that faucet that I showed you earlier, and it'll give you so much over a certain period of time that you can play with. So this is setting up the individual accounts. Turn on MetaMask, grab some Ethereum from one of the faucets for the test networks, and you can start sending transactions around the place, and you have a playground to work with. Okay, let's take it a little further. So we've got our playground set up. Let's look at that other part. If you remember back to the slide, well, the actual smart contract itself is what's deployed into the Ethereum network. So let's look at writing some of these contracts. Remember, we still got that really two other parts. Well, we got the account now too, because we got the account with MetaMask along with the Ethereum network. But we don't have that DApp code on the outside interacting with the smart contract. So let's worry about the smart contract right now. So here's what a contract looks like. It'll define which level of Solidity you're using. And what does it look like? Kind of a JavaScript, but maybe more of a C# because it's strongly typed. It's a class, right? So when you talk about these contracts, they're just classes, limited classes, that are then posted to the actual blockchain itself. And yeah, you have things like inheritance with the classes. I don't know about interfaces. And you go out and you create individual functions. You have constructors inside of it to work with. So it's a class, except it's called a contract. But when you're thinking about it, just think of it as a class. And the IDE that you can use, there's several. We'll see 3 of them. There's Remix, that's put out by Ethereum.org itself. There's Ripple, which if you're a JavaScript programmer, you'll probably love. Not a big fan. And you can even use Visual Studio Code. And a whole bunch of other types of editors. So basically all you have to do is go to remix.ethereum.org and start coding away. Another one is Truffle. Probably the unit testing is the best part in Truffle. And actually deploying out through Web3 if you're going to be doing that. And you can see an example here of Hello World. So you have a constructor, a set balance, and a get balance. pretty straightforward coding. Constructor, like all constructors, only once when you deploy the contract. And let's take a look at it. So I'm going to go back up to Brave and I'll go to Remix. I don't want to go all the way into it. So I simply go to remix.ethereum.org. And the first thing you'll get is a voting application. And voting is a great thing to use blockchain for, because you have these accounts that verify who you are, but other people can't see who you voted for. This is like I did a proof of concept for a firm that does the software for condominium voting, which, you know, South Florida, that's a big deal. So a lot of their, I think they have several 100,000 units that use their voting software. And they always had the problem with, you know, besides, you know, assuring accountability, the one vote per user, they always had the issue of, well, how do we say that we don't look up what their votes are? Well, you've got these accounts or wallets that are out there with the private keys. You write the code so that it can't be read by anybody but the account that actually made the individual vote. They can see the totals, they can close the voting, open the voting, and so forth, but they can't actually see who made the vote. However, you know that it is a valid vote. So voting is a big area. You saw it was one of those that was identified. They give you a voting sample. You just go into remix.ethereum.org and you'll see this. Notice across the top you have a compile. You have a run. And you can select how you want to run this and deploy it. Probably the easiest. Notice I have injected Web3 tied to RinkB because that's what I did inside of MetaMask. But probably the easiest one is go to JavaScript and you get 100 Ether for the gas payment and 5 different accounts. If you wanted to transfer between the two or have multiple accounts going in, testing your voting so other people can't see it and so forth. But basically it's an account that's a hash. So we have our accounts, we have basically our DApp, we have our virtual machine, our EVM to go against. We have what parameters are required inside of the constructor. What I'm going to do is create, notice, you got to compile. So you can compile it, you can do an auto compile as you're typing along. It's an IDE, you know, code completion. It'll give you warnings and so forth, give you Mr. Squigglies. Run, you can do analysis on it. You can test it. So create your own individual unit tests. You're running the code over and over and over and over in your test environments. You could have unit tests to run against them. You can step right into the code with a debugger. Sorry? Oh, how do you write the individual tests? What kind of so each one of the individual IDs have their own individual type of testing framework. So it's not gonna.
It's proprietary.
Can I what?
Related to another type of testing, or is it proprietary? I have no
So yeah, each one's going to have, and I believe it uses an is statement, and you walk through. I mean, it's pretty standard type of unit testing code. But does it fit into one of the buckets that's out there already? No. So all of these right through the individual IDE here. Let me go and create a new one. And we'll call it the FlaDotNet is too long. How do you? FL.net. There we go. So we'll call it FL.net signature. And one of the things that we're working on right now is that, you know, how are you going to start getting these blockchains deployed out there without using the individual public blockchain? And something that we're kind of seeing that customers are very interested in is document signing. What if you're able to take a hash of a document that, of course, if it changes, it becomes invalid, and post it to the blockchain so you now have an immutable record of that hash? Well, if you use the swarm, you can even put the document up there. I think there's a company out there called BlockSign that's doing it right now. There's a third-party vendor, Spherion, that has a add-in for Office. But basically, it's just taking a hash of whatever file you have and deploying it to a blockchain. But instead of a third party, what if they had it actually in-house on their own private blockchain? Or maybe a blockchain that they distribute among vendors. So you have that distributed. Everybody has a piece of the pie, can always get the audit from it. And then once you got the blockchain in, remember that big other part? You can come up with anything that fits into a workflow that meets that requirement of trust between enterprises, can fit into it and cut out the middleman. So I'm going to start this. Well, that's the environment. Let me hit a couple more slides and I'll go through them real quick just so you get an idea of the, well, no, I'll show you. I think in the later slides, just for time purpose, it goes through all the different types, you know, the different levels of access, inheritance, all of that. But I'm going to write a very simple, quick blockchain app or contract that will then attach to. So let's go back to the remix. We start out with a pragma. Let's say greater than 0.4.20. And then what do I call it? Let's say if I want to just grab that one thing. I want to identify a hash from a document so that I could then compare it later on and say, hey, this is the document that was signed. And I don't have to go through the third parties. I don't need to go through DocuSign. I don't need to go through Adobe. I don't even need to go through Spherion. I could use my own blockchain. So let's call it contract. And you can see the code completion here. And we'll call it contract block sign. And we'll now put a couple of properties out there. Well, we want to know who posted this, right? We want to know who the requester is. So one of the types is an address. Well, that address is the address of an individual account, a wallet, a private key, an identity. And the address we'll call requester. Oh, I'm sorry, address, and then we'll give it a scope public, and we'll call it requester. And then we'll do a string public. So you have all these different levels of scope, just like you would inside of a class. You don't want anybody to get to it except through the individual program itself. So now you gotta, and I'm gonna show you how wrong you can write something in this sample. Let's say public, and we'll call it the signature. So this is gonna be the hash, or hash sig. Make it a little more descriptive. We're now going to do a function What kind of function is this? It's constructor, right? Same name as the class or contract. And we'll call it a message. Doesn't really matter. And we're going to make this public. So I want to receive, so I'm basically creating a simple entry to grab the hash from something so that I could go back and say, here's this document, calculate the hash, is this in? Of course, you have a whole bunch of other properties that went by with it, right? But we're just going to do that one. So I'll say requester equals msg.sender. Oh yeah, you get this MSG object that you get a whole bunch of information automatically passed in. Want to see something kind of weird with this right in the contracts? Because you're going to be feeling, if you're, the programmer, you're going to be feeling constrained by Solidity. And that whole thing of you deploy it, you're done. You don't change it. Even though it's got these variables that you can change.
So I have some questions about what's the actual execution. So I clearly understand the concept of...
You want to wait until he
you might be talking about execution. Are you going to talk about it? You're going to hit execution?
So if you remember back, you've got this contract that's part of the blockchain that's executable code that you can call. Well, how do you call it? Well, here's all the concept of the D-app. And writing your JavaScript, React's a real popular one to write it in, and going through a Web3 provider, JavaScript Library, that connects in and you grab this code that you use inside of there. If you're a JavaScript programmer, you'll love it. You'll love Truffle. SIG, right? And we'll use the message that's being passed. So we're getting this, oops, let's make it consistent here. This message up here that's being passed. And then, because now you're actually writing the code that's going to have the edit checks of what you want to do inside this code and also the workflow related to it, which even gets a lot more difficult. Let me create, so this is the constructor. I deploy it, I got to pass that. So very simple, you want to just write a contract that grabs some properties, and that's basically what they're doing with like block sign and Spirion for the Office add-ins. That's all they're doing. Of course, they're grabbing a whole bunch of properties and so forth, and you have the option of putting the actual file into the swarm, so it's actually part of the VM itself. And it can be actually posted right into Bitcoin, into the Ethereum public networks. So if you really want a general, maybe like digital media and deploying it through those signatures out there, that's another huge area that they're working on blockchain now. So somebody comes out with their song, they just post it out to the blockchain. You don't access it unless you have the account.
Hey Joe, should that public be right after the function? Looks like it's generating an error.
Oh, is it? Did I put it in the wrong place?
I'm sorry, on line 8, should the public be...
Oh, no, this is the pragma. No, I think that's right. That's just the way that it's laid out.
Okay.
Yeah. Yeah, it's after the function. But I've got my, something's wrong with my pragma. Let's go take a look at the, I didn't put in my Solidity. Usually I have we take questions as we're going.
So, I program in C#. I have
Then this is very similar.
I have a class in data, and I can execute that one time, a million times. I can do whatever I want. Now, of course, with if it's deterministic, if it's the same input, I'm going to get the same output. I'm sorry. If it's deterministic, if I put in the same input, I'm going to get the same output, kind of like a hash function. But I want to understand, is a contract executed one time and written to the blockchain? Or is it
It's deployed one time.
Right.
Now it can be called many, many times.
Many times.
And it can be inherited or integrated into multiple contracts.
All right, so when you call it, you're passing in data, and that output from each call gets written to
the contract.
To the contract.
But there's a transaction in the blockchain also.
That's what I was looking for. All right.
So if you wanted to audit it back. But usually, like in the voting, you'll also have an entry either to it, depending on how big it is, you'll have an array that you can get all of the individual votes from, or you'll have multiple contracts that have a total contract that's just updating the totals, whereas the other ones are just individual transactions. So like the idea with this, you basically just want to do the constructor and that's it. Because you're just doing a one-time entry.
I also have a question. So that MSG.sender, what's that? Is it like a static class? Or
So that's an object that's actually passed to the contract. So you have all of these different things, kind of like a context. So like in the web, you can get what the refer URL is. You can get.
Yeah, but that's refer file is like
It's a global variable.
Yeah, think of it like in the web. You have the context object. You can see who the people are, who the referrer was, all that information. So MSG is inside of what's coming with the message into the contract. And notice there's not even code completion related to it. So you got to kind of look up what's available to the MSG object, at least in Remix. Because it also depends, like when we run this, we're going to have that third part out there, right? The app that interacts with the contract. And whatever that's going to be passing is going to go into that MSG object. So you could have you can actually write it and build that object yourself. which is why you don't have the code completion, because it's dynamic. So whatever you're using for that third part. Now, here is what you would never do in this type of a scenario. Let's go to function. Set sig. And we'll do a string sig. And we'll do the hash sig equals sig. So this gets you the idea that you can program, you're still going to have to rely on the programmer to put the edit checks inside of here, because you can basically write anything you want within your narrow frame. But remember, the idea of this is to create a hash that's only posted once, right? We just killed that idea. We just created we didn't, well, not yet. Now we have. We created a method that you could call and change it. So you're going to be writing this logic into it, and you say, well, wait a second, how do I rely on that? Well, if you look at tools like etherscan.io, and you go into the Ethereum public network, most people that post smart contracts out there post the code also into the swarm. So you can see and actually look at the code, audit the code, and say, hey, wait a second, I'm not going to rely on this hash. Anybody that has an address that has access to it, and you'd put the access in there also, right? Anybody who has access is going to be able to change this hash. I want it written once, but I've overwritten it here. Okay, let's see what we have here. Message public, what does it say here? Warning, it's just a warning. It's just saying that I'm going to use too much gas. It's warning me that you got to allocate enough gas, because these are the public networks. Yeah.
No, you had a question, Scott.
Oh.
No. When I said you have a question, he didn't put his hand while he was lifting up his hand 5 minutes.
So if you have a function like this, and essentially this can be changed, how can you verify that it's immutable? How can you guarantee that it's immutable?
Because you actually can look at the code and verify.
Right, but if you have a business application and you're selling it to the customers, they're not going to look at the code, so how can you still verify that it's immutable?
Oh, I don't think, as a customer, if it's a third party, I wouldn't do it without looking at the code. And whoa, wait a second, maybe there's a place for auditors and CPA firms here.
No, I guess I'm asking the question, if there is a function like this, is transaction written into the blockchain or history?
Yes. So you could always go back and audit the transactions.
So that constitutes a change to a contract, basically, right?
Right.
Something like that. Okay.
But yeah, if you're going to sign on to this, you're going to want to see the code or have somebody verify for you that, you know, it's not badly written, so it could be overridden.
But is it translated into something that people can understand? Like more user-friendly?
Solidity. No, you'd have to have somebody who knows Solidity. And not all smart contracts that go into the public networks have the Solidity up there also. But I don't think I wouldn't trust one that didn't. All right, so let's actually go and run this. What I'm going to do to get over my gas issue here is just throw a bunch of extra potential gas limit at it. And notice it says to deploy, I need to put in a message. That is a string. So we'll call this the first hash. And it has to be delimited. And notice you could actually load it from an individual address specifically. But I'm now going to deploy this, and it deployed to my JavaScript VM. I'm not even using my Rothstein with my, and it used a certain amount of gas. If I was using one of those other ones, you can get a real good detail of what this was and drill right into the Etherscan. If the code was published up there, you'd see the code, you'd see the individual transaction, all the details related to it, everything that's in that MSG object. And notice I have the setSig, my hash is the first hash, and then we have this hashed address. Basically anonymous, right? Unless you somehow could tie that together, which maybe in a private blockchain you might not want. In a public, you probably want it. And if I wanted to, let's make this the second hash. So that now when I look at, I wrote some bad code there, right? Well, at least it wasn't bad code, it just to the goals that I wanted it. But pretty simple to see. But it gets the idea that, hey, how you write this code matters. You don't change that code again. If you change that code, you deploy again, and you've got a new address that code's deployed to inside of the blockchain.
Is the address a code's address?
No, this address is an identity. This address is from up here, and if I changed it, so that'd be the equivalent of if you're using a cryptocurrency or wallet. But it's an identity. And how are you going to keep all those identities? So managing identity, writing this part of it here, that's the harder part. I mean, this is pretty, and it's limiting. You want to see something wild? There is none. There's not even a date type. If you want to get a date, it's when the actual block is committed. Or you pass it from the distributed app. But that third part out there that's interacting with it, this part that they're giving you to test it on. All right. So get the idea, Solidity, and we don't have to go through a whole bunch of code, you know. Now it's like, oh, what can I do? What can I do? How do I define this? How do I do workflows? Because this is a one-step workflow, right? Well, I threw in this extra set thing here that you'd never do. So you also have this thing known as Web3, JavaScript Library. And what you do is get the application binary interface with a bytecode. So you go and grab the bytecode of the individual contract, stick it into an object inside of Web3, and then you can write your HTML JavaScript application going against it and calling the contract. So that's how you do that third part. And that's what it looks like. So your whole ABI, you got the Web3 library, you have your Java application, whatever, HTML, JavaScript application. You go through Web3, do a RPC call, remote procedure call into the Ethereum VM. So if you want to have a boilerplate, and I'll put all these, I'll give Dave this slide deck. You have a reference there. So basically you do HTML, JavaScript, jQuery, web3.js, stick that ABI in there, and then you can even use MetaMask, integrate it right into MetaMask, so that instead of having that little thing down on the bottom, you get like a full screen of whatever you wrote on the side. And use React.js. That seems to be the most popular. Or you can use Azure Blockchain once you've got your smart contract written. What this does is scaffold up a complete, currently Ethereum, but the idea is that it's going to work with everything out there. The next one that they're going to be working on and deploying is Hyperledger. But it's basically a wrapper. Think of Web3 on steroids. So that you don't have to write in all of the workflowing. It'll create this intermediary app for you that does all of the heavy lifting. Still not trivial, but compared to writing React.js and working with Web3.js, it's very trivial and actually a lot more powerful. Okay. Additionally, remember that other issue? How do we keep track of all these accounts? In a public, you don't necessarily want to, but in a private, you definitely want to know who's doing what, right? You just don't want a hash of what the account was. You want to identify it directly with some type. So you gotta, like if you're maintaining that, you would have to maintain that all in the D app, or you would have to maintain it inside of the contract itself. Put in an actual identity along with the account address. What Workbench does is tie Azure Active Directory to the key vault where the private key is maintained. So how do you get an account? You log into Azure Active Directory. So your accounts are all taken care of with that. Additionally, you have a template. You run the template and it spins up everything necessary, including a SQL Server instance, because you might get the idea that this isn't really a very queryable platform, right? You're saying, oh yeah, it's got the transactions there, so you could, but it's not trivial. So what happens is that it actually integrates so that after it posts to the blockchain, anything that's public gets posted into a SQL Server database, and you can just use things like Power BI or Excel and write reports against it. So it takes about 15 minutes to spin up. And then I got a whole bunch of additional slides on coding and testing and so forth down here. But for the current time, we're already hitting 8 o'clock. Let me hop into this. So we got this contract here. Let me hop over and I'm going to go to portal.azure.com. Let me sign in. Talking too much. And I'm going to go into my resource groups here. And notice I have a blockchain HSI. And the cool thing is that you can actually deploy this with Azure Workbench to different regions and different subscriptions. So if you wanted to have some type of a quorum with external partners, they could be running it on their own individual subscription, all going through and communicating between all the different instances. And the cool thing is, like the SQL entry, it only gets written after the blockchain gets written, and only the public variables. So you have this great distributed type of an environment, all built off of blockchain, no disaster recovery, no ownership issues related to it. And notice all the things that it built here, networks and so forth. The most important, though, are the two app services. One is the API you can call and write your own individual programs, and one is the individual website. There it goes. Guess I didn't click on it. So it created an app website that interacts with the blockchain VM. And if you look, there's actually a VM, and when you set it up, you can set how many that you want to actually create. I think it's 2 to 4 instances in each location. So you can actually, you have to have at least 2 nodes running for it to be a blockchain. So I've got a URL here. Let's hop to that URL. And notice I'm logged in here as Joe Homnick. Well, inside of the key vault, there's a private public key that that individual account and only that account can pull out. And I have several contracts posted here. And notice that I have a hash sig. I'll show you the code in a second. Let me create a new contract, and we'll do the FlaDotNet signature. And I'm going to create it. And there it goes into the blockchain. I can go into the SQL database. The public information is right there. Notice it was modified by not a hash, but by Joe Homnick. I could have as many members, as many roles as I want. So it gives you this client, pretty extensive client. Eventually, they're supposedly going to make it so it's like embedded Power BI. So you can embed it into your own individual apps. So you'd only see the screens that you would interact with. And you can have multiple types of workflows in it. All right. So let's see how this all works. So I'm going to go into my desktop. Let's see, I've got actually, let's launch code. And notice I've got this directory here. And if I go into the Solidity code, yeah, it kind of looks like what we just wrote up. There's a little bit more to it though, right? So I have this state based upon an enum, and I'm setting the state, and I'm calling contract created. So what happens here is that you take your Solidity code and you wrap it up into, and here's an example of inheritance inside the code. You have a workbench base that will have certain functions related to it, and this is what ties you into the contracts that communicate with the outside. So you're basically erasing individual events here. I add this on here. So you add a few things in there, wrap it up into that event holder. Now, the other part. Notice there's a JSON file here. So remember I said this other thing is, how do you coordinate the workflow? When we were talking about that ride-sharing app, what was there, like maybe 8 steps in that workflow? What this will do, you have your description, oh, and who can use it? The application roles. So you might have a requester, you might have a driver, you might have a rating agency if the rating agency was on a separate blockchain or something. However, you can't call out from a contract. That's got to be all done on that external app. No external calls from inside of a contract. So notice here, I have this section of workflows. Well, this happens to be just a one-step workflow. Defining the individual properties, state requester signature, defining the constructor, and then we have the one send signature. And here in the state section, you define what state it is when it gets posted and what the next state is and how much percent complete. In this case, it's one step, right? So it's complete after the step, but just think of each one of those 8 steps that we had talked about earlier, just defining it out inside of the JSON and what functions it goes to. So what I'm going to do here is, just to show how this all works, let me copy this directory. And we'll call it FlaDotNet. And inside here, let's refresh this now. Inside here, I'll go and give it an application name of #sig FL .net. So I will change this to the contract. Let's see how to do that. Now I'll keep the workflows stay the same. I think you just have to change the name of the file itself. FL.net. And I'm going to deploy this contract. There it is. So where did I save it? Let's see, it's saved. So let's browse to the JSON. And let's browse to the Solidity code. Nope. Ah, didn't change those. Let's go back here. Go to the Solidity code. I think that's it. But you can see how the two interact here. Try it again. We'll put the JSON in here. And I deploy. So you get this client front end that you can then start using it. So we now have a, oh, I didn't change the name. Ugh. Now we know when that was deployed. Same day. But I'm guessing it's this one. I should change the name. Notice no members. You can start adding the accounts, and where do the accounts come from? Azure Active Directory. Here's the roles. Well, I just have one. Add it, and now I can start creating new contracts. And it's going through, posting, getting verified. Posted to the actual database, so you can pull it right out of SQL if you wanted to write reports on it. And we also have, come back to that in a second. Probably did something wrong. Let's go to the API. Because remember, we had a standard website. That was that client that it gave you. You also have an API that once you post this individual contract, you just call it in C# if you want to. They have a whole C# sample library out there. And here's the call for the applications. You can post the applications. So create the individual applications, create the individual contracts once the application is created. So basically you just have some calls that use this REST interface that executes against that back end. So remember, you got the contract, you have the account, you have the application going against the contract. Much more streamlined way of doing it, especially when you get into the extensive workflows. All right. So not trivial, but getting there. To the point where I expect it eventually is you'll have a project in Visual Studio that you'll deploy out to a test workbench. You'll have a VM built into Visual Studio and hit the F5 and debug. Have your unit tests all built in that you could run it against. But it's still in progress. They're still building it. And if you go the whole Web3 route, and JavaScript people love it, but most Visual Studio C# programmers wouldn't. And it's very time consuming and labor intensive. All right. I guess my password isn't good, is it? Questions, comments? So in a private contract, you're going to have a limited number of members. Public, anybody who wants to play can get in there.
And this is probably going to sound like a really ignorant statement because it is, because I legitimately don't know. If it's a public contract, everybody can see it, then they also see your transactions. So my competitors would then see all of my transactions. They know who I'm doing business with, how much money we exchange.
Right, which is probably you'll have private consortium types of that's going to be the vast majority of it. But if you're doing something like, hey, I want to deploy the latest music or the latest videos, and I want to maintain licensing rights, you got to go through the blockchain to be able to get to it. You got to have that account that's been given to you for some reason or another, and you probably have to pay to keep that account going. So there's public, but I think the very large part of it, public is really where it's at right now. But into the future, the private is going to be in the private consortiums. So, hey, you want to be my vendor? You're going to work inside of the blockchain. You want to know to the blockchain? Okay. But you're going to be running the transactions through the blockchain if you want to be my vendor.
And another ignorant question, if it's a public contract, you're using a public smart contract, it's not decentralized.
Yeah.
The opposite, it is.
It's centralized.
It is. It's decentralized.
Oh, it is decentralized.
Yeah, the whole idea with blockchain is that you got to have at least 2 nodes, but you really want more nodes than that, and you want them in separate regions. So like they just added the capability in Workbench. You can create a consortium so that you could have the actual EVMs running or Workbench instances running. It doesn't even have to. It could be just an EVM. And if you want to do all your Web3 programming and so forth against it, you can. But it's all part of that one blockchain. And a Workbench can be attached to any one of those individual nodes inside of the blockchain. So once you say, blockchain, and you say that verification process, that basically is a decentralized, although in this case I've got 2 nodes running in the same region, right? But this is a, proof of concept. If you're going to actually deploy it, you're going to deploy it across multiple regions and maybe even across subscriptions, different owners.
If someone wanted to secure their digital rights for like music or artwork or what have you in the blockchain, the probably the question that I have is digital media is subject to resolution. Like a document is not. If I create a contract of words, if I change one letter, it's got a different hash, all right?
It's got a different hash.
But artwork and music is subject to resolution. Each, if it's music, you sample the MP3 44 kilohertz, generate a hash of that output, it's going to generate one hash. You sample it higher, it's going to have a different hash. So what's the agreed upon mechanism? Artwork.
Well, first of all, there's no real agreed upon. Everybody's just just rolling it right now. It's still pretty early. I don't think you're going to see mass adoption for a couple more years in the enterprises. They're all working on their proof of concepts now. You're seeing some stuff out there. There's some like several thousand apps that you can go up to ethereum.org and see, or dapps.ethereum.org. So not a whole lot of those standards out there. Actually, there is something in Ethereum that I'm getting involved with, and they are creating standards of how contracts should be written. So you're going to actually have a best standards or best practices thing that you can say, hey, it meets these best practices on how it's written and deployed. So you'll have that. But in your case, I'd say, hey, you put out 5 different copies, they all go into the same contract, and you just have 5 different hashes. And you got to hit one of those hashes. If you don't hit one of those hashes and your account's not active, you don't have it. You don't stream it.
Is there a best practice for securing contracts within a private blockchain? For example, let's say you have a platform, you have a bunch of vendors doing some sort of bidding, and each time there's a contract, transaction, there's a contract in the history. but they don't want to see each other's transaction, but they own one blockchain. Is there best practice to ensure that, or
they are working on, and it's known as a consortium of different vendors or different nodes on how to actually do that. So they are building standards. Is there anything that's specific out there now? I think they have some rough drafts available.
Okay. There's nothing yet.
So it's something that's evolving. But these are things to think about. And identity to me is, I mean, figuring out how to maintain those workflows is one thing, which I think they've done a really good job here with the workbench. But identity, that's another one. And a whole white paper on how they integrate Azure Active Directory. And Key Vault's pretty cool because basically you don't have that account, you don't see that key. Microsoft couldn't give it to you.
So who's the most farther along in terms of models related to contracts? So you have a car, right? It has all kinds of different attributes about that car, like engine size, transmission type, et cetera, et cetera, et cetera. All of those would be implied as part of requirements for a contract. So when I buy that car, I'm getting that specific car that would have its own hash table based on model. Who's done the most work in terms of how all of that works?
So you're going to have to write that contract in as many properties, as many options. I mean, you might have just pull downs and so forth, drop downs that you're selecting the different options for. But once you actually write that contract, it's written into the blockchain and it's immutable. Can't be changed.
So that contract is based on a model. I mean, all those, you would have a different hash, you would have a different contract for every single type of model that you would sell.
Yes. And you can almost think of like this hash sig example, which is very, very simple type of an example. I mean, every contract, you create a new contract inside of here. See, I've got that one. So I've got the hash signature application, create a new contract. Fill in the constructor. Now, the other ones that have multiple steps inside the workflow, and they've got some great samples in there. You know, it's pretty extensive. Writing that code on your own is going to be tough. That's why I think the embedding of this is going to be important. He's giving a reference where you can get a bunch of standardized contracts.
So when you were mentioning about the security of the blockchains, so in 2017, Uber revealed that 57 million accounts has been compromised, basically. So when I do an Uber transaction, before I confirm the payment, right, it's an Best D app, which was developed from the days. So when we do that, so there was the measuring of the contracts which were missing, where Nick Sabu was the father of the smart contracts, which he created. So even right now, developers are trying to bring it to such an end where we can measure the contracts, because if we cannot measure the contracts, then there is no value of that, because we are literally passing the most exercisable legislative government rules and regulations to a machine to decide what is right and what is not right, basically. So in your findings, in your research about deploying the contracts, and how did you see where you can measure the contracts? Because when David wanted to send a contract to Wish, so, and the whole concept of the Bitcoins and the blockchain technology, when Satoshi Nakamoto was writing his paper, it's about duplication process. So when I sent a contract to David, Wish is sending a contract to David, so that contract is settling down in my decentralized database, as well as it is settling down in David's decentralized database. But over here, the duplication is again created. Because when David has to send to Jamie again a new hash rate is created. So for the same contract which has been generated from the wish, it's been duplicated same, and same. But how can we solve this problem when we are developing these contracts?
So a couple of things there. First is with the duplication, unless it's written into the contract that you can cause that to happen, I mean, that's part of the whole verification process. Now, second part of that is, unlike Bitcoin, it is a contract that has code. So you have a much higher attack surface there. So the whole duplication now, not necessarily that it's going to be duplicated inside the blockchain, but you might get a duplication that's based on bad contract code. So it uses the same types of verification processes and coming up with the hash, and you've got to have multiple people, and the more nodes, not people, but nodes, that you have verifying and saying that this is a valid block, including any possibility of duplicity, the more that the blockchain is going to work. Just like Bitcoin, except Ethereum's got, when you get into the smart contracts, you got a much bigger attack surface. I write bad code like I did on my sample there. That's not immutable all of a sudden. Well, at least that property is not immutable. And how about a vote? Oh, I only created one vote. Well, you could write code and have multiple votes. Because you can do multiple instances of the contract. And the addition might not work.
We use one of the algorithm which is called the Shor's algorithm to break anything else, basically. So when Shores were writing this algorithm, he took an inspiration of Alexander the Great mathematician. So like, how can we solve this factorizing problem? Because when Uber reported 57 million accounts has been compromised, so there was another code which was developed which is called Brain Fridger. It's another sister algorithm of the source algorithm. So my question was like, how can we write a code where, how can we encrypt a code basically rather than writing a code? How can we encrypt by using the cryptographic classical principles in the deployment process basically?
So once again, if it's a public, I want to see that contract. I don't want it encrypted. I want to be able to audit that contract. I want to know what's in there. Otherwise, you have trusted parties. You have a consortium of trusted parties.
Yeah, that's the main concept of Satoshi Nakamoto. Rather than, because from the ages when Tim Bradley has developed WWW, World Wide Internet, the main concept was to create the trust protocol between the two parties. So we cannot trust. If I want to make a transaction to my fiancé, to my family, I have to go through a third party, which is a bank, basically. So now if I'm hiring a person in my company, right, I do a 1099, but to validate the 1099 at the end of the year, I have to go through the IRS. And then that guy is a legitimate guy right now. But
and this is what blockchain, the idea with blockchain is going to solve.
Yeah, but
because you have this trustless scenario.
Yeah,
based upon.
The whole point is the IRS shouldn't be tracking it.
Yeah, but but the concept over here.
We have
like
a crypto anarchist over here.
100%. Freedom.
Yeah, and that's and we're gonna just say, yeah, that all works. We're just kind of looking at the smart contracts here.
Well, we'll make some observations. Blockchain today is back where VMware was back in 2005.
Give me a second, I'll turn it up. Can you speak a little louder?
Hello? 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 Okay. And so you've got to understand this stuff's going to have to mature, okay? There's nothing 100% because humans are involved. We're flawed. We write flawed code, okay? And you're going to find it just like VMware, but you notice what happened with VMware was they set the standard, and then the cottages popped up around them, okay, to fill in their holes. And if you want to make money off a blockchain, this is where you're going to make the money, okay? Not doing core blockchain. That's a commodity. It's going to be commodity work very quick. There's a lot of tools, a lot of automation that's going to kick in. You got to get where it's not and fill those holes if you want to make money, okay? And that's what I do, okay? So another thing I wanted to say is when you're looking at applications to use blockchain on, think of all the regulations that application is under. And one I was going to give you earlier was, remember when purchase orders went digital? And there were standards set, right? I was trying to remember what are those standards. I can't even remember them today. I used to know off the top of my head that when someone said, you do electronic purchase orders, yeah, there's a standard format, there's a standard way to do it, and it's secure, right, for that time. Today, purchase orders are, I wouldn't say they're pretty secure at all, you know, depending on how they're being stored. A lot of them aren't encrypted. But that's the great thing about blockchain, is going to make sure things are encrypted. So you got to understand, things have got to catch up. But if you're going to make money in this business, you got to go look outside the core blockchain functionality and look at the specialization areas. Start looking at existing applications that have funding, okay? And then applications that are going to make a significant difference to people's bottom lines. Preferably top line, driving money instead of losing it. And see, I work for a credit union, and so we're focused on like wire transfers. That's what we're targeting with this technology. We're working with Swift on it. But these are examples where the money's at to pay you to put your knowledge and skills at work to make money. And that's why I come to these things, to learn from different people how they're approaching it. And then I'm like you, I'm trying to understand where this stuff's going. But I got to remember, even though it's been around for 10 years, just like RFID was around for 50 years before it came in vogue. You got to give things time to catch up with it, but keep in mind, watch the laws that you're under, because now with GDPR and where your data resides, you got these nodes spread all over everywhere. Hey, when you get involved in European people doing European transactions, you're liable. So that's what you got to start. You got to do your discovery early on from the business side, regulatory side, then you jump into the technology ditch.
Yeah, public blockchain has no borders.
All right.
Coming from a banker, it depends on your audience.
All right, why don't we end the meeting? You can still hang around and talk. There's still maybe a number of...
One more comment here.
Here we go.
Sorry. I sponsored, so I'm going to be obnoxious and take the mic for a minute, even though I have no voice. So I'm a recruiter. Some of you guys may know me. Back when Homnick still ran Gold Coast User Group 20 years ago, people called me the Jerry Maguire of IT. I don't come to these events to recruit. I don't come to these events to find clients. I come to these events because I believe in technology. I'm passionate about tech, our ecosystem, our STEM startup ecosystem in South Florida. I organize TEDx events because, for the same reason, right? I just came back from, I'm currently building smart contracts for my recruiting company. So it's going to be smart recruiting because we're using smart contracts and we're building smarter companies. So I just went to a conference in Boston. We had 4,200 people from all around the world on stage. We had the VP of NASDAQ. We had directors from the SEC. We had tons of institutional investors and banks. And I got to personally speak with several very, very interesting people. One was the co-founder of Wikipedia. They've now created something called Everpedia. These are my takeaways that I'm going to share with you really quick. They created something called Everpedia. He got out after a few years because he said they were kind of beholden and it wasn't altruistic, believed or wanted it to be. So he always wanted to create a greater wiki. And now they've put this greater wiki, they're calling Everpedia, on the blockchain. The reason that's important is because it's on a protocol that governments can no longer censor what their citizens can or cannot see. Very cool. Everpedia. The other really cool thing I saw was Metal Pay. Who uses Venmo? Really? You guys are at a blockchain conference or meetup and only one person uses Venmo? Really? Dave, Joe? It's a PayPal company. Is that why? Cash? Okay, do you guys use cash? No? All right. Damn it, there goes the reference. All right, anyways. I know, that's why I think I downloaded it for my kids. Anyways, all right, so Venmo me, exactly. So this company called Metal Pay, I highly suggest you look at the app and download it. It is literally Venmo, except they pay you to use the app. They pay you in cryptocurrencies. So you do 10 transactions. I might send Joe $1 or send 20 people $1. All of a sudden I made an extra $1 that day or whatever. Very cool. So if you're using anything like Venmo, you might as well get paid for it, right? Metal Pay. If you guys want to know anything that I learned at the conference or you want to talk to me, please feel free to introduce yourself. Thank you.
All right, thank you. And you're going to sponsor too. So maybe the next meeting. So, yeah. Okay. All right, great. Thanks a lot, Joe. Appreciate it. Good talk. Thanks, Damien, for the video and the MC. Also, if you leave your card back here in the bowl, you can get a free day of co-working at Sendine. So, till next time. Thanks.